Hey everyone, I am absolutely thrilled to have you here today because, well, we're going to be unraveling a truly mind bending cosmic mystery. Have you ever actually stopped to question the absolute certainty of your own past? Today, we're looking at a fascinating new study from the Santa Fe Institute that basically turns our entire understanding of time, reality, and memory completely upside down. We are going to explore the universe's most unsettling loophole, and we're doing it all through the lens of pure, rigorous physics. Okay, let's dive right into this, because I promise you, this question is not just science fiction. It's a genuine mathematical puzzle that has literally kept physicists awake at night. What if the cold, hard laws of physics suggest that everything you remember, your childhood, your breakfast this morning, the very fact that you even started watching this explainer, never actually happened? What if it's all just a localized, incredibly detailed illusion? The eerie theory of the Boltzmann brain perfectly captures this whole unsettling idea. It suggests that our deep, unquestioned sense of reality could, theoretically, be born not from a continuous historical timeline, but just from sheer momentary cosmic chaos. To understand exactly how scientists arrived at this, frankly, terrifying possibility, we've got to look at the very forces that govern reality itself. Section 1. Are your memories real? Section 2. The arrow of time. So, we intuitively trust our memories because time feels like a solid one-way street, right? You break an egg, it doesn't unbreak. You remember the past, but you obviously don't remember the future. But to really understand that one-way street, we have to look to statistical mechanics and something called Boltzmann's H-theorem. Now, don't let the jargon intimidate you here. This is simply the foundational math tied to the second law of thermodynamics. Think of it as the rule book that explains why entropy, or cosmic disorder basically, tends to increase over time. This continuous increase in entropy is the exact mechanism that gives us our everyday, reliable sense of a past and a future. But here's where the story gets wildly unpredictable. The core mathematical twist is that the H-theorem itself is actually time-symmetric. That means the very equations that give us our arrow of time don't actually prefer one direction over another. Mathematically speaking, the physics work just as perfectly backwards as they do forwards. Section 3. The Boltzmann brain paradox. And this brilliantly illustrates the massive tension right at the heart of our reality. It's exactly in that mathematical blind spot where this whole paradox begins. On one side, we've got increasing entropy, which gives us a comforting, definitive sense of a real past and a real future. But on the other side, the underlying mathematical theorem is totally indifferent to the direction of time. Because the math doesn't care which way time flows, physics actually allows for way stranger possibilities than our human intuition can easily accept. Let this thought really sink in for a moment. Physics appears to allow the possibility that our memories aren't reliable records at all. From a strictly formal statistical standpoint, it's mathematically more likely that your brain, complete with every single memory, feeling, and perception you hold dear, just randomly popped into existence from the cosmic soup for a fraction of a second, rather than evolving over billions of years of real history. So, this brings us to the formal definition of the Boltzmann brain hypothesis. It's this deeply unsettling idea that physics literally allows for the possibility that our memories are not reliable records of lived events. Instead, they're impossibly detailed illusions produced entirely by chance. It's a staggering thought, isn't it? That the universe's math basically permits a reality where your entire past is just a momentary glitch. Section 4. Breaking the circular logic. For a really long time, physicists were totally stuck in a logic trap, trying to resolve this paradox. But recently, a team of scientific detectives from the Santa Fe Institute, Professor David Wolpert, Carlo Rovelli, and Jordan Scharnhorst, stepped in. They realized that how you analyze entropy completely depends on what you consider to be your fixed starting point. You see, some physicists assume the current state of the universe is the given, and then they work outward from there. Others assume what's known as the past hypothesis, which is a low entropy starting point back at the Big Bang. But the critical realization from the Santa Fe Institute team is that the laws of physics don't actually specify which of these perspectives is the correct one. It's entirely open to interpretation. So the crucial point is that when physicists debate this, they often fall right into a trap. The researchers call this the entropy conjecture reasoning loop. It goes like this. Step 1. You make an assumption about the past, like a low entropy Big Bang.
Step 2, you use that assumption to support your conclusion about why memory works and why entropy increases. And then step 3, you use that final conclusion to justify the original assumption you made in step 1. It's subtle. Actually, scratch that, it's not even subtle, it's just a completely circular argument.
The absolute beauty of what Wolpert, Ravelli, and Scharnhorst have done here is how they reframe the entire problem. They didn't necessarily set out to completely disprove the existence of Boltzmann brains. Instead, their work separates the pure, objective physical laws from the human assumptions we instinctively use to interpret them. By exposing that flawed circular logic, they've provided us with a far more transparent way to think about time, entropy, and the fundamental nature of memory itself. Which leaves us with this final, massive question. If the very physics we use to prove our past is real actually relies on hidden circular assumptions, what can we truly, absolutely know about reality? It's a profound mystery that keeps the boundaries of cosmology pushed wide open. I really hope this explainer has sparked your curiosity and maybe made you view your own memories and the arrow of time itself in a completely new light. Keep questioning the universe, and we'll see you next time.